Hello guys, hope you are all okay. Today I've made a video about acid-base reactions. I've made a table which actually summarize and differentiate between base and alkali and acid. Therefore, you can simply identify them whenever you come across any of them in chemical compounds or reactions. As you see, base and alkali are so similar except in few points. Both base and alkali, they neutralize the acid. Their pH level is between 7 and 14. In base, they are insoluble in water, whereas alkali, they are soluble in water. So, yet there again, we come across the word soluble and insoluble. And I need to make a point here that to identify the solubility of the compound, you have to refer to table of solubility guidelines again, as you've seen in the previous video for ionic equation. So this table is pretty much important because we use it quite a lot. Okay, so there are generally four rules for the types of the base or alkali chemical compounds which follow these formulas. For example, in the base, metal hydroxide, metal oxide, and metal carbonate, they form base. But you have to actually refer to solubility guideline table to check the type of the metal. You see here, to check the type of the metal if it is soluble or not soluble according to the rules in the solubility guidelines. Okay, so let's do a practice with one of the examples together. Okay, I get... Right. Okay, for example, there is metal hydroxide. Yeah, metal hydroxide. We say if you see a metal hydroxide, it's a base, but not always. Why? Because when I refer to this table, I see hydroxide is insoluble. Okay, but there is exception there. We've got exception for hydroxide. If we see hydroxide with any of the group 1 ions or any of the things here, they're actually soluble. So I check my example, it is iron hydroxide. The iron is not any of the group 1 ions, as you see, and therefore metal hydroxide, which have as example of iron hydroxide here, is a base. Okay, let's do example in number 3, metal hydrogen carbonate, which I've crossed it out because it's not at all a base, and we will look why not. If you look at this table, we've seen hydrogen carbonate as soluble compounds. So there is not any exception for hydrogen carbonate. That means you always see hydrogen carbonate in a compound. It is soluble. So there is no any exception for that. Therefore, because our basis is always insoluble, so hydrogen carbonate is not, and it's never in base, so I've crossed it out. Okay, so generally we've got number 1, number 2, and number 4 as base. Okay, and you can compare every example of here to the table, and you can figure it out yourself that how it works, the solubility. Okay, in alkali, the same thing. We've got 4 chemical compounds metal hydroxide, metal oxide, metal hydrogen carbonate, metal carbonate. So all of these could be alkali, but yet again we have to check the type of the metal if it follows the solubility guideline, right? So let's do this example, metal hydroxide, which is MgOH here. Okay, I refer to this table. The hydroxide is insoluble, but it can be soluble if it combines with group 1 ions. Yeah, and in our example, magnesium is in group 1. Therefore, magnesium hydroxide is a soluble compound. Therefore, it is alkali. As simple as that, okay? So you do this comparison for each of these as well to check if each of these metals are soluble or not soluble, okay? I make a quick note here that in our table it was lacking oxide because we will come across oxide in our compounds there. Therefore, I add oxide there because oxide follows the same rule as hydroxide. So it is always insoluble except when it combines with group 1 ions and all these things here. Okay, so it's pretty much, I think, easy if you want to predict because, like in oxide, that oxide means rusting the substance. So rusting substance couldn't be soluble, right? It doesn't make sense. So it is insoluble except this, except in here. Okay. Right. And the acids, they taste sour. The pH level is always between 0 and 7. They can donate hydrogen ions to bases. So an acid is proton donator and base is a proton acceptor. So what we means, because hydrogen, it has only one proton, so because we say acid can donate the hydrogen, that means it can donate the proton. That's why we call the acid proton donator. So in general, if you see a reduction in number of the hydrogen in a compound or substance in the equation, it's definitely acid. There are some example of acids I've put it here as, like there are lots of examples, so I've put some of them there. Okay, and finally, the types of acid reactions. Okay, there are generally 3 rules and 3 equations that we have to follow for acid reactions. It's really useful if you remember those equations because when you come across with the acid in the reaction, then you can easily write down the whole reaction or the whole equation. Okay, so number 1 is acid plus metal. When they react to each other, they give salt plus hydrogen. And I gave example. Number 2, if acid reacts with metal oxide or metal hydroxide, which could be either alkali or base, it will give us salt plus water. Number 3, if acid reacts with metal carbonate or metal hydrogen carbonate, it will give salt, water, and carbon dioxide. It's really easy to remember these 3 equations for type of acid reactions, and you can easily actually write your own acid reactions. Okay, this is the end of the topic for this topic, and I hope you guys understood it very well and have a good time. See you later.